Second ingredient of fine structure is coming from the spin-up coupling. So let's think about the spin-up coupling. As you know, hydrogen consists as a proton, plus ion proton, and revolving around the proton, then electron revolving around the proton. Let's see that let's assume that it is clockwise directional, moving around the proton. Then there is an electron in this case, and there is an electron spin, and angular momentum L. But how to imagine that the interaction between the S that R? Basically, spin-orbit coupling is the interaction between the electron spin and the orbital angular momentum. But both angular momentum can mixed by the single electron. So it is intrinsic electronic spin, and also moving around a proton can make that orbital angular momentum. There is no reason of the interaction between the S and R, but in the point of view electron, for example, in the point of electron can be is at rest at a point, and also proton, because electron is very small, and let's denote as a by point, and also a proton moving around electron. Here it is a proton plus, proton can moving around, and p plus. Then it makes that it makes the current, because the it is a circular motion of the proton can make that the current. So this current generates the magnetic field. So this kind of this classical point of view is not surprising. And anyway, it makes that magnetic field, and depending on the number of proton, here in this case, hydrogen atom can make only a single proton. Here it is r value, r vector here, and here it is velocity v. So, and it is internal magnetic field by orbital motion of proton can make that magnetic field. So from the Ampere's law, there may have the magnetic field generates by the mu 0 I over 2r, because current is that dq dt. So it is q is the elementary charge, and the t corresponding to the period. Then it is e over period is that because v is that 2 pi r over t, so, and the t is that 2 pi r over v, and angular momentum is that mvr, so, and the v makes that L over mr. So it is can be write down E over 2 pi r, and the v means that L over mr. So it makes that 2 pi mr square and EL, and that is the current. So magnetic field makes can be write down as that 4 pi m r to the cube and mu 0 EL. Basically, angular momentum is a vector quantity, and so magnetic field also vector quantity. Because we already know that here C is that 1 over square root epsilon 0 mu 0. So mu 0 is that 1 over epsilon 0 c square. So mu 0 can be replaced like this. So it is 4 pi epsilon 0 mc square r to the cube and el. So, and there may have, in this case, then the magnetic field is generated by the proton. So we can think that the magnetic field interaction between the electron spin, it is naturally imagined. So it is energy of interaction between magnetic moment by spin of electron and magnetic field by proton relative motion. So, and the magnetic moment represented by mu and the magnetic field represented by B. So energy of these two interactions is that minus mu dot B. Here, this mu is that the magnetic moment can be written down as minus GeS, but in electron, the gyromagnetic ratio is 2, so minus E over ms. So this energy means that it is a spin-orbit interaction, spin-orbit interaction energy. So it is write down spin-orbit interaction energy is that because minus value cancel or multiply by minus, so it is E square over, because multiply magnetic field and magnetic moment, 4 pi epsilon 0 m square c square r cube and L dot S. And actually, and it should be think that 1/2 should be multiply 1/2, and it coming from the Thomas precession. Thomas precession is the relativistic effect. It is relativistic effect due to the acceleration of electron. So this spin-orbit Hamiltonian interaction is that spin-orbit Hamiltonian is that by considering the Thomas precession and the E square over 8 pi epsilon 0 m square c square r to the cube and the L dot S. That is spin-orbit interaction of the spin-orbit Hamiltonian. Here in the is a spin-orbit Hamiltonian. Here we should consider this L dot S. We already know that L dot S can be matched at the total angular momentum. Total angular momentum J is that L plus S. And here, this L and S are not conserved, but the J is conserved. J is conserved. Then it is the J square. J square is that the L square plus S square plus 2 L dot S. So L dot S is that 1/2 J square minus L square minus S square. So, and it is well known that here J square and NLM is that the J and the J plus 1 H bar square, NLM and also L square and S square behave same manner. So it is not surprising. So here we can well define this L dot S. So this L dot S can be write down as the basically this L dot S is that the LX SX plus LY SY plus LG SG. Here LG SG, LG and SG is well defined also. So in this case, we define that ladder operator. Here, ladder operator. Ladder operator like this, and L plus is that the raising operator is that LX plus I LY, and the lowering operator is that LX minus I LY. Then it makes that LX is that 1/2 L plus L minus, and the LY is that 1/2I L plus minus L minus. So when you substitute this L dot S is coming from the here LX SX is that 1/4 L plus L minus S plus S minus, and LY SY is that minus because multiply 1/2I 2 times, so 1/4 L plus minus L minus S plus minus S minus, and also LG SG it can be defined. So when you expand this 1/4 L plus S plus L plus S minus plus L minus S plus L minus S minus, and second term is that minus L plus S plus L plus S minus plus L minus S plus minus L minus S minus plus LGSG. So this L minus S minus cancel with each other, and also L plus S plus cancel with each other, and also L plus S minus, L plus S minus, and L minus S minus, L minus S minus. There are two terms. So it is that 1/2 L plus S minus plus L minus S plus LGSG. So, and this ladder operator and LGSG can be defined by the quantum mechanical energy eigenvalue, and also this J square minus L square S square is also defined by the quantum mechanical energy eigenvalue equation. So, and we can calculate that the first order perturbation. For example, spin-orbit interaction of the first order is that this eigenvalue, eigenbasis is that NL. Here we should consider for the spin, because it is interaction between the spin and orbital angular momentum. And so here in the Adams coupling can define that total angular momentum J and Mj. So it is a coupled basis. And the Hamiltonian is the spin orbit part of the Hamiltonian, and the NLSJMJ. Basically, it is a coupled basis. So when you apply this Hamiltonian here, this term, this factor should consider. But here R is not the value, but it should be considered by operator. So NLSJMJ and 1 to the R cube, and also L dot S NLSJMJ. Then it is write down from the L dot S here, it is L dot S. So 16 E square over 16 pi epsilon 0 M square C square, and so expectation 1 to the I cube is NL. Here N is only corresponding to the R. So here LSJMJ only consider for the J square minus L square minus S square. LSJMJ. Here it is L dot S is coming from like this. Then we should also note that here this term star can be write down as the energy eigenvalue H bar square and J plus 1 minus L plus 1 minus S plus 1. And also this one 1 over R cube, and L is that it is known as A0 cube and cube L plus 1 half and L plus 1. So, and also we already know that here A0 is that H bar over alpha MC, and also E square over 4 pi epsilon 0 is that A0 alpha square MC square. So let's consider this spin-orbit interaction first order case. Here 4 pi epsilon 0 E square over 4 pi epsilon 0, so this term makes that 1/4 A0 alpha square MC square, and it makes that E square over 4 pi epsilon 0, and it is m square c square, and also it makes that a0 cube. So 1 over m square c square a0 cube, and the denominator makes that n cube l plus 1 half l plus 1, and here j plus 1 minus l plus 1. Here s is that the 1 half, so minus 1 half 3 half h bar square. Then it makes that 1/4 here a0 can be written down like this. Here mc square sort of cancel with each other, alpha square c square cancel with each other, and 1 over m, and a0 1 over a0 square, it makes that alpha mc over h bar square. It is a0 square, it makes that. And also remaining one is that h bar square j plus 1 minus l plus 1 minus 3/4, and also n cube l plus 1 half l plus 1. So it is that 1/4 alpha to the 4, and mc square and the h bar square cancel with each other, and also here. Then in this case there is a problem. What kind of problem? It is that for l equal to 0, it is s orbital. It's l equal to 0 case, and this denominator equal to 0. It is meaningless, and it makes that denominator is 0. So the numerator should be 0. So it makes that the j plus 1 l equal to 0, so should be 3/4. It makes that, and the j to the 1 half and l equal to 0 and s equal to 1 half. How to exclude this? How to exclude this l equal to 0 case, and in more general expression, and we should include the s orbital. So in this spin-orbit coupling case generally, and L is not 0 because spin-orbit coupling is that S plus L, so S and L should be defined. So L should not be 0. And the fine structure, as you hear in the previous lecture, we already studied for the fine structure by the relativistic effect, and the resulting in the fine structure energy finally, fine structure energy by relativistic and spin-orbit coupling is that here fine structure first order energy correction is the summation from the relativistic plus spin-orbit interaction. So when I write down, and relativistic correction is that the minus 1/2 alpha to the 4 mc square and 1 over n cube L plus 1/2 and minus 3/4 n to the 4, and it is a relativistic effect. And also the spin-orbit coupling makes that this energy correction, so it makes that energy correction. So, and let's summarize. In the 1/4 alpha to the 4 mc square, the first term j plus 1 minus L plus 1 minus over n cube L plus 1/2 L plus 1 and minus from here, because 4, so it is 2 over n cube L plus 1/2, and also this term plus 3/2 n to the 4. It is let's write down, it is equation A. Here in this case, and for s orbital case, basically s orbital is that L equal to 0, but basically, and the s orbital is a spherical symmetric orbitals, and also how to exclude the L equal to 0 case. Here in this case, let's consider further J. This L can be write down as by J, and because J equal to L plus minus 1/2 case. Let's separate the case. In the first case is that the spin up L plus 1/2 case. Then it makes that L equal to J minus 1/2. Then this fine structure first order case is that it makes that 1/4 alpha to the 4 mc square and 1 over n cube, then j plus 1, and L is that j minus 1/2, and also L plus 1 is that the j plus 1/2 minus 3/4, and L is that j minus 1/2, and L plus 1/2 is j, and the L plus 1 is j plus 1/2, and minus 2 over L plus 1/2 is j, and plus 3 to n. Then we should calculate this term star. Then star is that the denominator is j minus 1/2, j plus 1/2, and the numerator is the j square plus j square minus 1/4 minus 3/4 minus 2 over j. Then it is j square cancel with each other, and it is j minus 1/2 So j minus 1 half cancel with each other. So it is j plus 1 half minus 2 over j. Then it is j plus 1 half. Then it is 1 minus 2 j plus 1 half. Then it is cancel with each other. It's minus 2 also j cancel with each other over j plus 1 half. So this fine structure first energy correction 1/4 alpha to the 4 mc square 1 over n cube and minus 2 over j plus 1 half plus 3 over 2n. Then in other words, it is minus 1 half alpha to the 4 mc square 1 over n cube, then 1 over j plus 1 half plus minus 3 over 4n. It is case for the L plus 1 half. And secondly, in the case of j equal to L minus 1 half case, in other words, L equal to j plus 1 half case. And let me see this equation A. Fine structure first order, because it is that 1/4 alpha to the 4 mc square. Let's make that 1 to the n cube. Then L is that the j plus 1 half. L plus 1 half is that j plus 3 half, and the L plus 1 is that the j plus 1. Anyway, and the j plus 1 minus j plus 1 half. L plus 1 is that the j plus 3 half minus 3/4 and minus 2 over L plus 1 half is the j plus 1 and plus 3 over 2n. So let's calculate this term. It is a 2 star. Then 2 star is that j plus 1 half, j plus 3 half, j plus 1. Then numerator j square plus j minus j square plus 2j plus 3/4 minus 3/4 minus 2 over j plus 1. So j square cancel each other. 3/4 cancel. Not cancel. It is not cancel. So it makes that minus j minus 3 half. So it is minus plus, so it cancel with each other. So it is j plus 1 half, j plus 1 minus 1 minus j plus 1 half. Then it is j plus 1 half, j plus 1 and minus 1 minus 2 j plus 1 half. Then this numerator minus 2j minus 2, then is minus 2j plus 1, and j plus 1 cancel each other, so minus 2 over j plus 1 half. So finally, this fine structure first order is that minus 1 half alpha to the 4 mc square 1 over n cube, then 1 over j plus 1 half and minus 3 over 4n. This result is the same with this j equal to n plus 1 half case, because this result and this result is identical. So it makes that it do not consider for the L because L and S is not conserved, but the J is conserved, so the expression in J is more reasonable. Then also it depends on the J but not L, so the singularity at the L equal to 0 is gone, so it is reasonable. And finally, then when we draw the picture of the energy level in the Bohr energy is that n equal to 1 case, n equal to 1, n equal to 2, or the n equal 3 case, the Bohr energy level is degenerated. But here the hyperfine interaction can have a splitting like this, and it is 1s 1 half, and the is triply degenerated, 2p 3 half and 2s 1 half and 2p 1 half case. And also this energy also split 1 2 3 and 3s 1 half, 3p 1 half and 3p 3 half, yeah, 3p 3 half is degenerated, and also 3d 5 half. And also it is known that the energy spacing is 43.8 gigahertz, and here it is 2.74 gigahertz. So it is 13.7 gigahertz, and as here 0.54 gigahertz, and in this 1.62 gigahertz, and here it is 4.87 gigahertz. It is a fine structure. It is a fine structural result, and this it makes that the high frequency oscillation of electron motion, and between this energy scale it makes that very high frequency like a gigahertz energy level. So it is a fine structure, can make that relativistic and also spin-up coupling can make the another degenerated energy level splitting.